Hello and welcome to the next instalment of Python Statistical. In part 3 we look at refining the mathematics in finding turning points. In the previous video we implemented a method for locating turning points in time series data. A very simple example was used. In this video we will add a little more complexity to the very simple time series example. This will show that further refinements are required so that only turning points are located. So I've written this Python code to show that the current method finds more than just turning points. So let's run this code to get a pictorial representation of what I am talking about. So we can see there are 2 points in this time series example marked with a pink and red dot, where basically the direction of the line has not changed. The first one shows a slightly declining growth but still in a positive direction, and the second point shows accelerating growth again in the same direction. This may be good information to include in a model. If a leading time series is showing accelerating or decelerating growth, then a lagging time series would hopefully show the same pattern. However, first we need to see if the lagging time series is following the turning points of the leading time series. If the lagging time series is not following these turning points, then it should be excluded from consideration. I've labelled the 2 turning points and the 2 non-turning points from A to K, as shown here. So let's look at the first turning point, B minus A, which is negative, but C minus B is positive. Looking at the next turning point, we have D minus C, which is positive, and E minus D, which is negative. For the first non-turning point, we have G minus F, which is positive, and H minus G, which is also positive. So looking at the second non-turning point, we have J minus I, which is positive, and K minus J, which is also positive. So basically, the first differences of the turning points always change sign, whereas the non-turning points have the same sign. This table summarizes the turning points and non-turning points. The non-turning point can be both positive, as in climbing towards a maximum, or both negative, as in descending towards a minimum. Python does have a sign function, and the next table shows the result of when we take second differences of the signs. We can see that for the minimum turning point, we get a positive result when we take second differences, and for the maximum turning point we get a negative result when we take second differences. However, when we take second differences for the non-turning points, we get 0, and therefore it is not classified as a turning point. Going back to the Python program, I'll copy across the code snippet that uses a sign function. And I'll comment out the other method. So to use the sign function, we just write mp.sign. So it uses a Numpy method for that. And we do that around the first differences as we outlined in the slides. So I'll just run this. And now we see that the two non-turning points are not identified as turning points. I'll stop the video here. If you liked the video, please give it a thumbs up and subscribe to the Python Statistical channel. If you disliked the video, please give me a thumbs down. Thank you.